Okay, we are into our second lesson for Chapter 8, Solving Linear Equations. Hopefully Lesson 1 was good to you. You were okay with it. We are still going to continue to work with fractions, decimals, rational numbers. So making sure that you are good at working with them. So the first part of this lesson is helping you remember some fraction operations as well as some one-step equation stuff, okay? So just as a quick review, these first three I'm going to ask you to solve and then verify your solution. So remember, we have 4 times q. We need to isolate the variable by doing the opposite operation. So if it's being multiplied by 4, we're going to divide by 4 on both sides. So q, remember, if we are dividing a fraction, we multiply by the reciprocal. Same gives us the same answer. And we get -5 over 24. Okay, I'm going to be looking to see if you have verified on your own. So I'll help you solve these, but you're going to need to show me how you verified them. Looking at the second one, we're dividing by 3, so the opposite is timesing by 3. Again, I'm going to be looking for you to verify it. My hint for you is use the improper fraction to verify. That will usually make things a little bit easier. Looking at the last one, we have y in the denominator, so we're going to multiply both sides by y to get it out of the denominator. 16.5 is -5.5 times y. Now we can divide both sides by the coefficient. So we get a -2.818181, so it's 2.81 repeating. If we put that into a fraction, it would give us -2 and 9/11. Okay, but again, you could substitute 2.81 and it should be pretty close for you. Okay. So again, I'm going to be checking for you to have done that verification. So some more review. We are adding and subtracting fractions. Why do we need to review this? Because we've been doing it since grade 7, and some of you are still adding denominators or subtracting denominators, and it makes my heart hurt every time I see it. So we're going to not do that anymore. So before you can add or subtract, you are going to make a common denominator. You're doing all this extra work, so once you've made that common denominator, keep it. Don't change it by adding them or subtracting them. So the most simplest way to make a common denominator is by multiplying the denominators by each other. So we're going to multiply this first fraction by 5, and we're going to multiply the second fraction by 3. Common denominators, now we can add them. We're dealing with the same size pieces. 11 out of 15. Okay, I'm going to fly through these. I'm actually just going to put up the answers. I'll show the second one, but the rest of them I want you to just solve, check the answer. If you didn't get any of them right, come and see me tomorrow. Okay. 5, 6, take away 1/3. I know that I can turn 3 into 6, so I'm just going to times by 2. Okay. Gives us 3/6, which in lowest terms is 1/2. So making sure all your fractions are in lowest terms, because I'm going to write the answer in lowest terms or proper form, which might be a mixed number. So you need to be able to know if what you've got matches that. For C, you are subtracting, so you should get -1 and 1/28. For D, you are adding, make sure you get a common denominator, you should get 1 and 17 over 28. For E, you're subtracting, and this is a negative, so keep that in mind. You should get 1 and 7/15. And for the last one, we're adding, and you should get 2 and 5/9. Okay, so I'm not looking for your answer on these ones. I'm going to be checking for your work. No work, no credit, and then I give you lots more fraction practice to prove to me you can do it. So just do these ones. Okay. The good part. So we're solving two-step equations. We did these last year, but what I want you to remember is that we need to isolate the variable. And so we want to start clearing away the things that are furthest from the variable, like the constants or the things that are being added, and then work our way closer and then deal with the coefficients or the multipliers to get the variable by itself. If we start dividing first, sometimes it works, but sometimes it makes our life a lot more difficult than it needs to be. So just kind of as a rule, let's follow BEDMAS backwards. Get rid of any of the adding or subtracting, any of those constants first, before we deal with the multiplier or the coefficient. So 3y minus 5, identify my variable. My variable is y. It's being multiplied by 3 and it's being subtracted by 5. So I need to deal with the times by 3 and I need to deal with the subtract 5, but I'm going to deal with the subtract by 5 first by using the opposite operation. So I'm going to add 5 to both sides. Minus 5 plus 5 cancels out to 0, right? If we're thinking of 0 pairs or opposite integers, when you put them together, they equal 0. So now we get 3y equals 15. Now I can deal with that timesing piece by dividing both sides by the coefficient, and we get a y equals 5. Okay, and if we just do a quick check, 3 times 5 is 15, take away 5 is 10. So yes, that does work for our answer. Moving to the second one, we have 5 times r plus 7. So our variable is r. It's being multiplied by 5 and added by 7. So we need to undo the add 7 and we need to undo the times 5. We're going to undo the plus 7 first. 7 plus 7 gives us 0, so we get 5r plus 0 equals 22, take away 7, which is 15. Okay. Undo the multiply by doing the opposite, which is divide both sides by 5. So then we get r's value 3. Just quickly in our head, double check. 5 times 3 is 15, plus 7, that's 22, so we're good. Next one, x divided by 2 plus 5 equals 20. So again, there's our variable x. It's being divided and it's being added. So we need to get rid of the adding before we get rid of the dividing. So opposite of plus 5 is subtract 5. X divided by 2 plus 0 equals 15. Opposite of divide by 2, we're going to times both sides by 2. So x equals 30. Just quickly in my head, 30 divided by 2 is 15. 15 plus 5 is 20. So that one works. So we're doing the exact same thing here. Two-step equation. However, we do have rational numbers. So we're dealing with fractions and decimals now. Okay? Sometimes you can turn your number into decimals and it makes your life a lot easier. So sometimes we work with them as fractions. So I'm going to show you kind of both examples. You decide what you want to use, just make sure it's appropriate for the situation. Okay, so 2x plus 1/10 equals 3/5. I'm going to solve this one as fractions. I'm noticing that the denominator is 10, so I'm actually going to change the 3/5 into a denominator of 10. So I'm going to multiply by 2 and get 6 out of 10. Okay, so 2x plus 1/10 equals 6/10. Same value, equivalent fraction, just with the same denominator now. So now I can get rid of this plus 1/10 by minusing 1/10 on both sides. So 2x plus 0 equals 6/10 minus 1/10, which gives us 5/10. Okay, I could also show 5/10 as half by dividing top and bottom by 5. So 2x equals half. So we're timesing by 2. We're going to divide by 2. Okay, so that's the same as x 1/2 divided by 2. Kiss and flip. So that's times a half. So x equals 1/4, or 1/4. Okay, so that's keeping everything as fractions. In the second example, I am going to show you keeping everything as a decimal. Okay, so when a denominator is 2 or 4, I know that they make a decimal. So I'm going to put them in decimal form. So instead of 1/2k, I'm going to put 0.5k minus 0.5 equals negative 1.75. 3 divided by 4 is 75, and then negative 1 goes in front. Okay, not so bad. So now I'm going to solve it just like a regular two-step, as if there were no decimals. So plus 0.5 plus 0.5, 0.5k equals negative 1.25. Okay, if you want to think of that as 50, like 50 cents, maybe that makes it easier. And then divide by 0.5 on both sides. So k equals negative 2.5. If we wanted to put it back into a fraction, k equals negative 2.5, because 0.5 is half. So that's how we could solve as a decimal. A third option for you is noticing, let's get rid of the fractions altogether. So thinking about, okay, what do I need to multiply everything by to get rid of the denominator? Well, I have 2 over 1, so there really is no denominator with the y. 1/2, I would need to multiply that by 2 or some other even number. And 3/4, I would need to multiply it by 4. So I'm going to multiply this whole equation by 4 over 1. Okay, so kind of like it's a coefficient up front. I'm just making the whole equation 4 times bigger. So I'm going to go 4 times 2y. So 4 times 2, that gives me 8y over 1, plus 4 times 1, that gives me 4 divided by 2, gives me positive 2. 4 times 3 is 12, divided by 4 is just 3. So the 4's technically cancel each other out. So now we have 8y plus 2 equals 3. Well, that's kind of easy to deal with. So again, isolate my variable, work backwards BEDMAS, subtract 2 on both sides first. So then we get 8y plus 0 equals 1. 8 times y, do the opposite, divide by 8. So y equals 1, 8. Okay, so again, we ended up with a decimal in the end, but when we had to do any of the adding or subtracting, we ended up with a whole number instead. Okay, so for these last 3 questions, I'm going to say solve them how you like. The first one is still in fraction form, so decide for yourself, are you going to leave it in fraction form and solve with common denominators? Like the first example, are you going to turn it into decimals? Is it something that you can turn into decimals, or maybe are they repeating decimals, or are they non-terminating decimals? That could be annoying, and then this method won't work. Or is it something like you want to do like letter C, where we got rid of the denominators altogether? So think about what you would need to multiply to make that happen. E and F, I've been very nice to you. They are decimals already, so hopefully they're nice and easy to solve. I will check these 3 from you tomorrow.